Lesson 8.3, we talked about how to find the directional angle of any vector. There is a formula that we can use to find the angle that's just between two vectors. So if we want to find that, the formula is cosine of theta. That's theta is the angle between the two vectors. It's the dot product of vector u times vector v divided by the magnitudes of those multiplied by each other. Okay. So let me show you how to do this, and then I'll talk about why we want to do this. So we want to find the angle between each set of vectors here. So we want to find this angle. So we're going to use this formula. Cosine of theta is u times v. So 4, 3 times 3, 5 over the magnitude of u. Now remember, that's a modified distance formula. 4 squared plus 3 squared. And modified distance formula for v, 3 squared plus 5 squared. All right, so we're going to get cosine theta. In the numerator, we're going to do 4 times 3. Those are our x components. And then the y components, 3 times 5. And then in the denominator, let's see, 4 squared plus 3 squared, that's 16 plus 9, so that's the square root of 25. And then 9 plus 25, that's the square root of 34. So we have cosine of theta is 27 over 5 root 34. Okay. I think I did that right. Does everything look okay there? Looks good. Okay. So now we're going to put that into our calculator. When you do that, make sure you put your entire denominator in parentheses. You're going to do inverse cosine of 27 over parentheses 5 root 34. And your calculator is going to tell you that theta is 22 degrees. All right. And if you wanted to see a picture of that, I guess we didn't draw a picture. Here we go. So we have this vector u, which is right 4 and up 3. So maybe it looks like this. And then a vector v that's right 3. That's not super great. And up 5. So maybe something like that. So this angle in between them is 22 degrees. That's what we just found. All right, let's check out another one of these. So we've got these two vectors. I'll go ahead and draw these since I didn't do that before. So vector u is 2, 1. Looks like that. Vector v is 1, 3. So maybe it looks like that. And we're trying to find this angle between them. So we're going to do the cosine of that angle between them is vector u times vector v over the magnitude of u, so 2 squared plus 1 squared, times the magnitude of v, 1 squared plus 3 squared. So in the numerator, that's going to be 2 times 1 plus 1 times 3 over, let's see, this is going to be the square root of 5. That's going to be the square root of 10. So we can write that as cosine theta is 5 over the square root of 50. And that's good enough. You can put that in your calculator. Inverse cosine of 5 divided by the square root of 50. That's a 50 there. And your calculator is going to tell you 45 degrees. Okay. So angle between vectors, this actually has some really cool applications as far as search engines. I'm going to post a video by someone else, I didn't make it of course, that talks about how search engines basically use vectors and they're looking for the smallest angle to give you back good hits, which is kind of cool because you use search engines constantly. All right, something that a vocabulary term we haven't talked about is orthogonal. Orthogonal is just another word for perpendicular. Two vectors are orthogonal, perpendicular, if the dot product is 0. Orthogonal vectors have a bunch of applications in more advanced classes. We don't really need to talk about those yet. Right now, we just want to answer the question is, are these two things orthogonal? So we're just going to take these two vectors and multiply them and see what happens. So we do 2 times 6 plus negative 3 times 4. And we get 12 plus negative 12, which is 0. So the answer is yes, they are orthogonal. That was easy. All right, we'll do the last 2 problems in the next video.